so again, we have about 10 problems to go through today. So like I said, a little bit longer than usual. I'm going to try and go through them as quickly as possible though, and I will end up posting this at the end. There were a few people on the testing list today for one of the two tests that was going on today. So classroom looks a little empty. I think I had like 5 or 6 people from this class. But let's go ahead and go over these. Again, all of them are dealing with quadratics. Some of them are solving using things like quadratic formula, factoring, completing the square. Others are taking quadratic and graphing it. On this first one, it's asking us to find the vertex of the parabola with the function that was given. This is what we call vertex form. So there's 2 different formats when it comes to our quadratic equations. When we have something in this format, that's vertex form. So I'm going to write that right here, vertex form. And I'm not sure which way Mr. Genghis had mentioned it or how it may have been in your notes. Do you remember using an H and a K? Does that sound familiar at all? No? All right. So it can be written a couple different ways. Sometimes they use an H and a K. Sometimes they use this would be C and D. Again, it doesn't matter. What this is telling us though, when it's in this format, it's called vertex form for a reason. H and K is the vertex. So H is our vertex. So on here, all we have to do is identify where's the H, where's the K, and pull them out of the equation. Now, the one thing you have to be careful of in this format is the H value that's inside the parentheses here. It has a negative in front of it, even the original vertex. So when we take that 4 out, it actually changes signs. So it's going to be a positive 4 when we take it out. And our K value will stay the same because the K value is positive in this format. So we have 4, 9. That would be our vertex. And that's actually all you had to do on this problem. There's no other work. So since it's in vertex form, we're just identifying what those 2 values are from that format. Now, the next question is currently in vertex form, and they want us to rewrite it in standard form. So we're going from vertex form to standard form. Well, what's standard form? Standard form is when we have it in the format of y equals AX. That's standard form. So we have to multiply things out in order to get this into standard form. First, dealing with the parentheses that are being squared, we have to actually go through and square that. So we're going to have essentially our distributive property to multiply those 2 values together, because that's what x plus 1 squared is doing parts. X times x is x squared. X times 1 is 1x. 1 times x, 1x. 1 times 1 is 1. The 2 in the middle are like terms, and we can combine those. So we have x squared plus 2x now, plus 1. This was all for this middle term. Now, there is a pattern. Anytime we square anything, what we have from this part of our equation, the first term ends up being squared. The last term ends up being squared. The value that we get in the middle of this trinomial is both terms multiplied together times 2. It'll always follow that same pattern. Now, whether you want to remember that pattern or not, that's up to you. You can multiply it out every time like I just did, but and if you want to save time, there is a pattern. Now that we've done the power, we can do the rest of this equation. So we have a 3 out here in front still. We still need that out here in front. And that's still, so we still need to make sure we have that on there as well. The 3 that's out in front, again, it was in front of parentheses. So it is getting distributed to all 3 values in the parentheses. So this now becomes 3x squared. Now the last 2 values are like terms. They're both constants. They don't have a variable on them. So these 2 we can combine. We have the 3 and the -7 will give us -4. So our final answer is 3x squared plus 6x. Our final answer for this one in standard form. Any questions on that one? All right, going on to the next one. What is the vertex form of the quadratic? So this one's using an idea of completing the square. When you have a equation in standard form and when I go backwards to vertex form, you have to do what's called completing the square. Currently, this is not a perfect square trinomial. We want to make it into one. So what we're going to do, we are going to take the first two values, we're going to rewrite them. Then we're going to write plus and leave a space. All right, leave a space. And then we're going to put plus 18. And I'm going to do one more thing. I'm going to add again and leave another space. We're going to complete the square for this first set. We want to make this a perfect square trinomial. Now, there's a pattern to a perfect square trinomial. So the way that we can do this is we take that middle value, what we usually refer to as the b term, we divide it in half and then square it. So I'm going to take that b value. Let me change my ink color for a second. This b value. So that's b. We take b, we divide it by 2, and that's what we're doing. So on this one, it's 10. So we're doing 10 divided by 2, and then squaring it. 10 divided by 2 is 5. 5 squared is 25. We need to add on to make this a perfect square trinomial. But I can't just change the value of my equation, so I have to balance it. Well, in this case, I'm adding values to the same side. So I'm adding 25 here, but I can't just add 25 because it's not balanced. So over here, I'm going to subtract off that same 25. So we just completed the square. Now that it's a perfect square, we can take those terms that are in the perfect square, and we can change this entire set of parentheses to a binomial that's squared. So we're going to switch out the parentheses with something that's squared. Well, what we're going to do, we're going to take the square root of this first term. So we're going to square root whatever that first term is. Then we're going to take this last term. Oops, I didn't mean to put the, where's my eraser? I was supposed to say x squared. I forgot my x value. Well, I'm going to take the 25, take the square of that. So square the first term, square the last term, and the sign that's in the middle, that's what we use in the middle here. So what is the square root of x squared? It's x. What's the square root of 25? It's 5. The sign from the middle is positive. So this is now, again, a binomial that's squared. That last term, we have 18 and negative 25. If we combine those, we're going to get a negative, what is that, negative 7. And then this would be my final equation. So my final equation in standard form is y equals x minus 5. Now remember, your exam is all multiple choice, right? This one. So since it's all multiple choice, could you use some test taking strategies if you forget some of these steps? Yeah, you could try and narrow down your answer. You could plug values in and see if you come out with the same value. And again, you could narrow down your selection. So keep that in mind, because if I had an equation at the beginning and plugged in 0, for example, I should be able to come up with 18 from that equation, right? Because the first value would cancel off, middle value would cancel off, I'd be left with 18. If I plug 0 into my final answer down here, I should get the same value. 0 minus 5 is 5, 5 squared, 25, 25 minus 7 is 18. So again, if you forget how to do that, it's okay. Use test taking strategies to get you through it, all right? You can find a correct answer without doing all the math that we just did. All right, let's move on to the next one. Solve by square root method. So square root method is exactly what it sounds like. We are taking a square root of both sides in order to get our answer. So right now, on the left side, we have the 2. So this is a perfect square. We're square rooting the left side to get rid of that square. Whatever we do to the left, we got to do to the right. So here, the square root and the square cancel off. And it's going to leave us with x minus 2 equals, and I'm leaving a little bit of space here. Square root of 36 is 6. But if I take a square root when I'm solving, I actually get 2 answers. Because I could have 6 squared would have given me 36, or negative 6 squared could give me 36. So this 6 is both a positive or a negative 6. So when you're solving, you always get two values if you're taking a square root. Then finally, we have that -2 has to come over. So we have to add 2 to both sides. So what do we end up with? Well, we have a +6 plus 2, or we have a -6 plus 2. So our final answers are +8 or -4. Yep. Anytime you solve a quadratic, you normally get two answers. There is a possibility of getting one answer or a possibility of getting no final answer, but most of the time it's going to be two answers. And the reason that is it comes back to our graph. Right? Whenever we graph something that's a quadratic, it looks like that. It looks like a parabola. And normally it intersects our x-axis twice. So anytime you're solving any type of quadratic, you usually get two answers. Only times that there's exceptions is if we are square rooting something that's a negative, or if we have, once we square root, we get the same value for both of them. All right, 22. Solve by square root method. All right, same thing. Solving by square root method, taking the square root of both sides, get rid of that square, gives us 5x plus 5. Square root of 100 is 10. And we get both a positive and a negative. Each step of the way now, we have two values that we're finding. So first thing we need to get rid of is the plus 5. So subtract off 5 from both sides. We're going to have 5x equals, and we have a positive 10 minus 5. We also have a negative 10 minus 5. Whoops. So we have 5x equals either. Then we have 5 to get rid of. Divide it off. Dividing it off of both of those. Our two answers are a +1 or a -3. Uh, 23. State the vertex of this function. Again, this is in vertex form. So just looking at it, we need our h value and we need our k value. So on here, we have a -4 and -5. Which one of those do we have to change the sign for? Do we change it for the x value or the y value? So it's going to be the x value, which is our h, the one that's grouped with x here inside the parentheses. It's going to stay -5, and that's our vertex. So again, the h starts off as a negative, so we have to change its sign. The k comes out same as it is. All right, solve the equation by completing the square. So on this one, we did complete the square earlier, but we did that one for an equation where we had to graph or find our vertex, I believe it was. This one, we actually want to find values. So it's very similar, but the first thing we're going to do, we're going to go ahead and move that 33 over to the other side. So we have x squared plus 14x plus, we're going to leave ourselves a blank again. But now, how do I get this 33 over to the other side? I'd have to subtract it off because I got to do the opposite to move it across the equal sign. So I now have a -33 on the other side. I'm also going to balance this equation. So I'm going to add a blank to this side to balance that equation. So just like on the other problem where we're completing the square, I'm taking my b value, which in this case was the 14. So it's b divided by 2 squared. So 14 divided by 2 squared. 14 divided by 2 is 7. 7 squared is 49. That's what's going in my blank. Now, the last time I did this, I added the number to the same side of the equation to balance it. Here to balance, I'm going to go ahead and add it to the other side. So since I added 49 to the left side, I'm adding 49 to the right side. So it's going to be a +49 again, because we're on different sides of our equation. So whatever I added to the one side, I had to add to the other. Now we have a trinomial that is a perfect square. So this whole thing is a perfect square. I'm going to change it to a binomial. that is then squared. So taking the square root of the first term, taking the square root of the last term, I'm taking a sign from the middle. Square root of x squared is just x. Square root of 49 is 7. Sign in the middle was positive. On the right side of the equation, I had negative 33 and a positive 49. When I add those, I get a difference of 14. Did they give me something that doesn't work out very nicely? We're on 24. Oh, I lied. That's not 14. I didn't even double check my work. I should have. All right. Try that again. 49 minus 33, that'd be 16. Now it should work out nicely. I'm going to rewrite this one more time just so that we have a little space to work. Because now it is a perfect square on this side. They want us to go all the way and solve. This wasn't just complete the square. This was solve by complete square. So now that we've completed the square, we can solve. We're going to get rid of our square by square rooting both sides. So we now have x plus 7 equals positive square root of 16 is 4. And finally, to get x by itself, we have to subtract off 7. We're going to write it over here. So x equals, we have a positive 4 minus 7. And we also have a negative 4 minus 7. So we get two answers. The first one is negative 3. Second one is negative 11. All right. Moving on to number 25. Oh, sorry. I might have changed that kind of fast. All right, number 25. Use factoring to solve the equation. So on this one, we have our equation, x squared plus 9x plus 18 equals 0. All right. Well, on that one, we did factoring a lot yesterday. So to factor this, we are taking our a and our c values. Again, our a value on this one is 1. Our e value on this one is 18. The 9 in the middle, that's our b value. So a times c is what we're doing first. 1 times 18 is 8. We're looking for factors of that value that adds the middle. So factors of 18, we have 1 and 18, 2 and 9, 3, 6. Well, that's a positive number. So only way to get a positive is if we have either two positives or two negatives. The middle term was a positive. So to get a positive when multiplying and a positive while adding, both numbers are positive. So going through those, which one adds up to 9? It's going to be the last set. When I add those two, I get a positive 9, which is my b value. So that's what I'm using to split this. So we get x squared, 6x plus 18 equals 0. Factoring by grouping, group the first two, group the last two. Take out your common factor. So we get x. We're left with x plus 3. On the other set, take out a common factor, which would be 6. It also leaves us with parentheses, which we do. So we take those out together as a factor. And the x and the 6 come together as my other set. What are my solutions? Since they're asking us to solve, each one of these factors has to be set equal to 0. So x plus 3, x plus 6 equals 0. And then solve each one separately. So subtract 3, we get negative 3. The other ones of negative 3 and negative 6. Now, what's the faster way of doing this on the exam? Do we need to know how to factor? Yes. However, if we're solving something that could save you time, they're going to give you values. If you take those values and plug them in, you have to get something that's true. If I take negative 3 and plug it into that equation, I'm going to get 0. Same thing if I plug in the negative 6, plug it in, I should get 0. So use good test taking skills, find your answer. And if you can avoid doing all the work that we just did, that's fine. There's other ways that you can go about finding the correct answer that are sometimes faster, especially with a multiple choice test. All right. And also, if a question asks you to solve by factoring and you want to use a different method, that's fine too. On the exam, it's multiple choice. They're not looking at your work. So if you want to do every problem like this next one, that's fine. This is the quadratic formula. Quadratic formula is a good way to solve because it's the same steps every single time. Now, you would have to know this formula. I'll have to double check. I don't remember if they give it to you for the liberal arts final or not. But this equation, negative b plus or minus the square root of b squared minus 4ac all over 2a. So you're plugging into the equation to solve. 5 is my a value, 6 is my b value, 1 is my c value. You just have to make sure that your equation is already set equal to 0 before you plug into this equation. If it's not set equal to 0, move your values over so that it is, and then you can plug into the equation. So we have x equals, the b value here was 6, so negative 6 plus or minus the square root of, again, b was 6, so 6 squared minus 4, a was 5, so times 5, and then c was 1, so times 1. On the bottom, we have 2a, so 2 times our a value of 5. Normally, when I plug in values, I usually always put them in parentheses. Good rule of thumb there, put them in parentheses, because if you wanted to go and plug this into a calculator right now, you could possibly plug that whole thing into your calculator. And if you're using parentheses as you plug in, then they'll ensure that your answer is correct. All right. So we have negative 6 plus or minus square root of. Simplifying these parts, 6 squared is 36. We only have one negative, so this is going to stay negative. 4 times 5 times 1 is 20. 2 times 5 is 10. Again, continue to simplify. Negative 6 plus or minus. The difference between 36 and 20 is 16. The square root of 16 is. So now we have 2 possible answers, because we have the first one is going to be a negative 6 plus 4, which will be negative 2 over 10, or negative 6 minus 4, which will be negative 10 over 10. So we either get a fraction that's reduced to negative 1/5, or we have a whole number of, sorry, not a whole number, we have an integer of negative 1. And those would be our 2 solutions. Again, it's asking you to solve. All your answer choices on the exam would be numbers, so you could essentially plug them into your equation, see which ones give you 0. All right, last one. So on this one, it said for each graph, label the vertex, axis of symmetry, and the solutions. So on here, these are kind of small. Let's start with the vertex for each one. So for each one, identify where your vertex is. So the vertex is the point at either the top or bottom of your parabola. So points that I just labeled in red, those are my vertices. On the first one, that is at 4, negative 1. So also make sure you look at what units your graph is in, because you have all these little lines and you have the bigger lines. The bigger lines are marking them off in groups of 2. So whoops, 4, negative 1. I said, I forgot to write my 1. On the second one, that was at negative 2, positive 1. On, oh, sorry, that was C actually. Kind of goes in a strange order. B, were yours on your paper up and down? Maybe I cut it that way. Yeah, that's right. It's going out of order. All right. On B, we have 0, negative 2, it looks like. And on D, negative 1, 0. So first thing we did was identify what our vertex was. Let me change colors for the next part. So now, axis of symmetry. Whenever we talk about our axis of symmetry, it is going to be the line that goes through that vertex. So Each one of these, I'm putting a green dash straight down through our vertex. Well, since we already found our vertex on each one of these, we line and say x equals, and it's whatever the x value was of our vertex. So the first one is x equals 4. For part B, it'd be x equals 0. For part C, it'd be x equals -2. For part D, it'd be x equals -1. So again, vertical line is set equal to x. So we just had to look at what the x value was from that vertex. And the axis of symmetry always goes through the vertex. Solutions. All right, solutions are going to be wherever it crosses our x-axis. So on the first graph, it's going to be these 2 points right here and right here. This first point is going to be at 3, 0. So for solutions, I can just write that it's 3. The second value is at 5. Again, we just need the x value, the x coordinate from those points. So we have one at 3 and one at 5. Then on B, does it go through the x-axis at all? No. So since it doesn't go through the x-axis, there is no solution. On C, it goes through the x-axis. The first one's at 5, 0. The second one, sorry, negative, I said that wrong. -3, 0. It's very small there. -1, 0. So we have values at -3 and -1. Those are 2 solutions. The last one is also kind of special because our vertex that we have there is the only point that's on our x-axis. So we also have a solution here at -1. There is no second value on this one. So since it's only intersecting at the vertex, there is only one solution to this. And I believe that was the last one I asked you guys to do. Yep. So that was our review questions for quadratics. Again, I'll give you a little sheet. I'll post it on Canvas as well. I'll set the due date out for 2 days. So if you haven't got the other one done yet, I had also set the due date for tomorrow for that one, just in case you need extra time. Same thing for this one. I'll set it out 2 days. So again, if you want to work on the review, the main review packet first, that's fine. For tomorrow, I'm only asking you to have 32 through 36. So it's a smaller group of questions for tomorrow on the packet. I believe all those were dealing with linear equations or linear functions, equations of lines, things like that, slope, parallel. So all dealing with different things with graphing lines. So those are the ones that we'll do tomorrow. Any questions on the ones we covered today? All right.